Hi everyone, welcome to my channel. I am Mimi and today I am simulating a model of free convection. First, select the heat transfer physics and the time dependent study. Save your project. Then select the unit of your dimension of the geometry and enter the parameters. Then insert the geometry value. Select material for both geometries. I have chosen iron for both cylinders and the box. Then we proceed to the heat transfer physics. Boundary conditions. The bottom boundary is kept at 200 degrees Celsius. The upper boundary and overall cylinder boundaries are convecting to 20 degrees Celsius with a heat transfer coefficient of 5 watt per meter squared Celsius. Proceed to mesh. Select free tetrahedral mesh for this model and select study to compute. Now we can see the temperature distributions of this model. The red area is the lower temperature area, whereas the yellow area is the highest temperature area. In this example, we assume that there is only heat transfer to the surrounding air, neglecting any conductive heat transfer, other heat transfer. This example also initially assumes that there isn't any fan forcing air over the cylinder. Thus, the transfer of heat to the air is via natural or free convection. As the part of the cylinder heats the surrounding air, the air gets hotter. As the air gets hotter, its density decreases, causing the hot air to rise relative to the cooler surrounding air. These free convective air currents increase the rate of the heat transfer from the part to the surrounding air. The air current depends on the temperature variation as well as the geometry of the part and its surrounding. Convection can also occur in any other gas or liquid such as water and transformer oil, but in this example, the discussion is primarily around a convection in air. Thanks for watching. Bye.